Think about your last drive. You were likely operating a 2-ton machine at high speed, surrounded by other machines, yet your mind was probably elsewhere. This effortless performance is a cognitive illusion. Your brain, honed by millions of years of evolution, has automated a task of immense complexity. It seamlessly processes a flood of data: the subtle lean of a cyclist, the flicker of a distant brake light, the texture of the asphalt. An autonomous vehicle has to learn this intuition from scratch. And it's in the moments where our intuition works best that the machine is most fragile. Programming a car to stay in its lane on a clear day is the easy part, the first 99% of the problem. The real challenge lives in what's called the long tail of probability. These are the near infinite number of rare, high-consequence events that happen every day across the globe. It's not a pedestrian crossing the street. It's a pedestrian in a large, inflatable dinosaur costume crossing the street during a hailstorm. It's a sheet of reflective mylar from a birthday balloon, temporarily blinding a car's LiDAR sensor. You can't write a rule for every possibility, because the number of possibilities is fundamentally uncountable. To build a complete picture of the world, these cars use a principle called sensor fusion, combining data from cameras, radar, and LiDAR. A camera sees color and texture, radar sees velocity, and LiDAR sees precise depth. When they agree, the car has a high-fidelity model of reality. But what happens when they contradict each other? Consider a large photorealistic image of an open tunnel printed on the side of a semi-truck. The camera screams pathway, but the LiDAR and radar scream solid wall. Resolving this sensor paradox in the fraction of a second before impact is not just a coding problem, it's a philosophical one about the nature of truth. Driving is a social activity, governed by more than just law. We navigate a complex web of shared assumptions and intentions. A driver waving you on at a four-way stop is a negotiation. A ball rolling into the street creates the immediate prediction that a child might follow. This is called theory of mind, the ability to attribute mental states to others. An AI doesn't have this. It might see a person waving their arms erratically by a broken-down car as just a moving obstacle, failing to understand the urgent message, danger ahead. Engineers try to solve the long tail problem by running billions of miles in simulation. They can create virtual snow, rain, and traffic. But simulations are, by definition, a simplified version of reality. They might not account for the specific way sunlight glints off a piece of road debris thrown up by another car. They might not model the bizarre aerodynamics of a plastic bag caught in a crosswind. This is the sim-to-real gap. Reality will always be the ultimate adversarial network, capable of generating scenarios that your simulation never conceived of. For the software on your phone, an error rate of 1 in a million is spectacular. For a fleet of 1 million cars, that's one potentially fatal error per trip. The standard for safety is astronomically higher. This has pushed computer scientists toward a field called formal verification, which uses mathematical logic to try and prove that software will behave correctly in all possible situations. But how can you mathematically prove a system is safe when you can't mathematically define the infinite chaos of the real world it has to operate in? The proof is constrained by the imagination of its creator, but reality is not. The strange truth is that humans are not exceptionally reliable drivers. We get tired, we get distracted, we make poor judgments. Our advantage isn't perfection, it's adaptation. Our brains are general-purpose problem-solving machines. If we see something we've never encountered before, like a flock of geese calmly sitting in the middle of a highway lane, we don't search a database for a goose on road protocol. We use analogical reasoning, physics intuition, and predictive modeling to slow down and navigate around the unexpected. We improvise. So, the quest for autonomous vehicles is not really about building a better driver. It's about solving the problem of artificial general intelligence. It requires a machine that doesn't just recognize patterns, but understands context, causality, and intent. The edge cases aren't just glitches to be patched, they are fundamental tests of a machine's comprehension of our world. And until a machine can truly comprehend, the final, most dangerous edge case will always be the one that happens next.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.